Hello students, thank you for taking the time to watch my video. In this video, I will be going over some of the very basic but extremely important mathematical concepts like exponents and significant figures. Make sure you take good notes and write down questions as needed by pausing the video. Let's get started. The first concept we are going to talk about is that of scientific notations. And scientific notation is basically a way to take some really long numbers, like 78 billion, and condense them into a smaller form. We do that by first taking a decimal and writing it right after the first whole number. In this case, my first whole number is 7, so I'm going to write 7, put my decimal, and put 8. And from now on, what I'm going to do is get rid of all my zeros, but I'm not going to completely get rid of them. I'm going to represent them in a different manner. And so in this case, what I have to do is I have to count how many places did I jump my decimal. So if I assume my decimal was here, then I went 1, 2, 3, 4, 5, 6, 7, 8, and 9, and 10. I'm sorry, there you go. So what I did was I took a large number with 11 digits and I rewrote it, and so it looks a lot less intimidating. It looks a lot cleaner. It's 7.8 times 10 to the 10th power. What about if we have a really small number, like 0.000752? I can clean this up using the same exact rule that I just talked 2 seconds ago. I have to take this decimal and I have to move it, and I did 1, 2, 3, 4 places. So what I'm going to do is I'm going to write 7.52 times 10 to the negative 4. So the rule of thumb here is if your decimal is traveling left, then you get a positive exponent. If your decimal is traveling right, you get a negative exponent. Just for some quick practice, go ahead and convert the two numbers on the screen to scientific notation. Make sure you note them down in your notebook. Now that we know how to write scientific notations, it is important that we know some basic rules to follow when trying to multiply or divide numbers with exponents. Here on the screen, I have two numbers, 3.5 times 10 to the 6th power and 2.5 times 10 to the negative 2nd power. And what I'm trying to do is I'm trying to multiply these two numbers. Now, you could just put them in the calculator and get the answer, but on exams like AP Chemistry, you don't have this option. So you need to figure out a way to manipulate the exponents around so that you can get an easy answer. And so the rule here says that if you have two numbers and both of them have the exponent with the base 10, now this is very important, that both numbers must have the same base of the exponent, which in this case is 10. And if that is the case, all you need to do is, because you're multiplying the numbers, you add the exponents. And so by adding the exponents, what I get is 10 to 6 plus negative 2, which gives me 10 to the 4th power. And so I've taken care of my exponent part. Now what do I do with the other two numbers, which is my 3.5 and 2.5? Well, those I will just have to multiply in the calculator. And so when I do that, my answer is 8.75 times 10 to the 4th power. Now you could do that without needing a scientific calculator, because on a 4-function calculator, which is what you get on most of the AP exams, you will not be able to do this unless you know the rule of exponents. So it is extremely important that we keep track of these little things. So just like we had a specific rule to help us out while multiplying numbers with exponents, there's also a rule to help us divide numbers with exponents. As you can see, I have 1.6 times 10 to the 8th divided by 2 times 10 to the 4th. Just like we did in the previous problem, what you will do here is you will isolate your exponents, and because they have the same base, which is 10 on both top and bottom, what you will do is you will go ahead and subtract the exponents. Because you are dividing the two numbers, you subtract the exponent, and so what I get here is 10 to the 4th, because 8 minus 4 gives me 4. And as far as the actual numbers go, you can simply divide them, and right off the top of my head, I know that 1.6 divided by 2 should give me 0.8. Now, for those of you who understood the previous topic over scientific notation, you will realize that this number is not in scientific notation because my decimal is not after the whole number, it is before the whole number, and I can't have that. And so I have got to move this over here. I'm moving the decimal one place to the right side, and what I then get is 8.0 times 10 to the third power. Remember, I moved my decimal to the right, and so I had to go down on my exponent. Alright, and so this is how you multiply and divide numbers that have exponents. Before we go any further, I want you to think about something. See, we all know that numbers have a very specific meaning. If I tell you I'm 33 years old, I want you to think about the accuracy of the statement. I am in fact not 33, but 33 years and 5 months old. And even this is not completely accurate. As a matter of fact, the only time I was 33 was on my birthday. And so now we can say that significant numbers or figures are those numbers that we are certain about. Like, I'm certain that I'm 33 years old, but not sure the exact time of my birth, so I don't tell everybody exactly how old I am. Indeed, there are strict rules that must be followed, especially in science when performing mathematical operations on numbers. You cannot simply multiply, divide, add, or subtract two numbers without taking into account their individual certainty. So let's take a closer look at what these rules are and how do we use them. Rule number 1 is pretty basic and simple. It simply states non-zero digits are always significant. What does that really mean? Let's say I have a number 6,387. All you have to do is count how many digits this has. Turns out it has 4 digits, and so in this number I have 4 sig figs, or significant figures. Now the problem really comes when we encounter zeros. Zeros are notorious for causing confusions, so it is extremely important that we get this right the first time. Rule number 2 says any zeros between two significant digits are significant, and all leading zeros are insignificant. I'll talk about what leading zeros are in a second, but let's talk about the first part of the statement. So in this example, the number I've chosen is 680009. We've already seen that every digit that is not a zero is significant. And rule number 2 says that because I have 3 zeros between my two significant figures, 8 and 9, I have to count them as significant as well. And so in this case, the total number of significant figures in this example would be 6. Now let's talk about the second half of the statement, and that has to do with the leading zeros. And so the term leading zeros means the zeros that lead to the first significant digit in my number. In this case, that number is 6. So how many zeros do I have here? I have 4 zeros. And what does the rule tell me? It tells me that they are insignificant, which means I'm not going to count them. And this is where we will take the help of our friend scientific notation. What I will do is I will take this decimal and I will move it until I get to my scientific notation point, and I will write this as 6.89 times 10 to the negative 4th power. And now it is pretty obvious as to how many significant figures we have, which is 3. Rule number 3 states that trailing zeros are only significant if a decimal is present. Now let's talk about what that really means. On screen, I have two numbers that look very similar, with one major exception is that the second number has a decimal. And so let's talk about what trailing zeros mean. A trailing zero is a zero that is after your last significant non-zero number, which means that in this case, my last significant non-zero digit is 8. Any zeros after that are only significant if a decimal is present, which is only the case with the second number. And so in my first example, these zeros are insignificant and I only have 2 sig figs. But in my second example, I've got a decimal point, and what that tells me is that this is an accurate measurement. And in this case, I will have to record this digit, this number, as having 5 significant figures. Now that we know how to determine the correct number of significant figures, let's talk about how to perform the 4 mathematical functions on them. In front of you are 2 numbers with different number of digits after the decimal point. Which of these 2 do you think is more precise? It would be 1.0952, because we have made this measurement to the 10,000th place as compared to 3.65, which only goes till the 100th place. And so if we compare these 2 numbers, this is the less precise, this is the more precise. And so now let's talk about how do we add these 2 numbers. To understand this properly, I think the best way to do it is to write it out as you guys did in elementary school probably, which is to write the 2 numbers one below the other and matching your decimal point. Once you've done that, let's see. I've got 2 over here because there's nothing above it. Got 5 over here because there's nothing above it. And I've got 4, 7, and 4. So I got a number that has 1, 2, 3, 4, 5 significant figures. But the rule on the top tells us that the answer must represent the least precise measurement, which in this particular case happened to be this one. And because your least precise measurement has 3 significant figures, my answer must also have only 3 significant figures. So I will write this out as 4.7. And then for the third and last significant figure, I have to pay attention to my 4th figure, which happened to be 5. Now you know if a number is 5 or above, then you round the number up. That's before the number you're eliminating. And so this 4 right here becomes a 5. Okay? And this is how you would add two numbers with different numbers of significant figures. Let's take another example, and this time we're trying to figure out how to solve a subtraction problem. And so in this case, I've got two numbers, 16.8724 minus 3.7. As you must have noticed by now, my least precise measurement is 3.7, which has two significant figures. Therefore, the answer that I get here should also have only two significant figures. So what I did was I laid this out just like in the previous problem, and let's see what we get. And the answer comes out to 20.5724. Remember what I said? You can only have two significant figures. In this case, I've got 1, 2, 3, 4, 5, 6 figures over here. And I can only have two. So I'm going to get rid of this, I'm going to get rid of this, and I'm going to get rid of this. I am going to get rid of the 5. However, because it is the 5 right after my second significant figure, and because that 5 is a 5, I will have to round this 0 up as 1. And so my final answer would be 21. I can see how this could be a little confusing, but I promise you that if you do enough practice on this, which we definitely will be in our class, you will get the hang of this. It's very important that you must not lose track of your least precise measurement, because that is what is going to tell you how many sig figs will your final answer have. Now let's see what happens when you're trying to multiply or divide two numbers that have different numbers of significant figures. So the example in front of you is 36.0 divided by 4. In this particular case, my numerator has 3 sig figs, my denominator has 1 sig fig. And as the rule says, the product or quotient must have the same number of significant figures as the number with the least number of significant figures. I know it sounds a little confusing, but if you look at the example, you can compare that between these two, this is the one that has the least number of significant figures. And so when you do 36.0 divided by 4, your answer is 9. It's not 9.0, because if you write 9.0, that would mean that you have two significant figures, but you don't. Similarly, if we're multiplying two numbers that have different number of significant figures, like in this case, I've got 3 sig figs, and in 1.7 I've got 2 sig figs. And so how do I proceed when I'm multiplying two numbers that have different number of significant figures? Again, you go with your answer must contain the least number of significant figures, which in this case happens to be 2. So if I do this on the calculator, my answer is 6.0, it's 6.205. This has 4 sig figs, but we can't have 4 significant figures because our answer, our number only allows us to have 2, and so we're gonna have to get rid of some of these. So we're going to get rid of the 5. We're also going to get rid of the 0, but because it is right after the last significant figure, when we get rid of this, we have to pay attention that it is a 0 which is less than 5, and so your answer would be 6.2. This number has two significant figures, which is the same as the multiplying numbers with the least number of significant figures. And that is how we manipulate numbers in chemistry. As with everything else, you will not master the craft of sig figs unless you practice a lot. Thank you for watching and happy learning.